Hello, welcome to Permutations 2. I'm assuming you watched my Permutations 1 video. The last question we did together dealt with the 12 marching bands, right, who won first, second, and third place, and we talked about the formula. So we're going to continue with that. Okay. Again, listen to my language. I'm going to use the same language. Get in some good vocabulary. Make sure you watch the other videos I post that aren't mine. Some people have amazing videos out there that go with permutations. Okay, first one of the day. 2 students are chosen from a group of 6 to read the first and second poems in the school poetry reading. To find out how many different ways the students can be chosen, I didn't finish my sentence. It's kind of a ... Okay, so I have 6 kids, and I'm telling you that the first and the second is important to me, right? Someone's going to read first, someone's going to read second, and that's me telling you that the order matters, okay? So I have, here's my first kid that's going to read a poem, and then here's my second kid that's going to read a poem. No offense to the other 4 kids, but they're not getting chosen. So I have 6 different kids who could come and read first. And then I have 5 different kids that could read second. Okay, altogether, I have 30 different ways I could choose 2 kids to come and read first and second. Actually, I'd like to go back and have you think about what a tree diagram would look like that goes with this. I could name the kids Kid 1, Kid 2, Kid 3, Kid 4, Kid 5, Kid 6, right? 6 kids. So it would be 6 kids read first, right? And then from there, branching out. If Kid 1 reads first, then in my second tree, I would only have 5 kids read second, okay? And if Kid 2 read first, then I would still have the other 5 kids that could read second, but Kid 2 can't read second. So the tree would get smaller as you went on, but there would be 30 different ways that you could choose those kids. Okay, 9 kids are running a race. How many ways can they finish? This is me being nice. I care about all 9 kids. Okay, so this is going to be a factorial because I care, okay, somebody comes in first, comes in second, comes in third, right? This is 9 factorial because I care about all the kids. So either you're going to take your calculator and figure that out, or you have a factorial button on your calculator and you're going to figure it out. Okay, next. This one, I hope you're getting the gist of this. If I'm asking how many ways 5 people can stand in line for a movie, okay? That's my nice way of saying I do care about all 5 of them. But when I say how many ways can they stand in line, that's me also telling you the order matters, so it is a permutation. So 5 kids can stand in line. First, I pick someone. 4 kids are left to stand in line. Next, I pick someone. 3, 2, and 1. Okay, also known as 5 factorial. And then you can figure that out on your calculator. More importantly, I want to get into the language of this. This could also be 5 CDs that I listened to that we talked about before, or it could be 5 books I'm putting on a shelf and I want to see how many different ways I could put the books on the shelf. Okay, so it really is, I'm going to start playing with, instead of people, I can make it any object that I want. Okay, and that is 120. Notice 4 is different, okay? There are 6 runners. I only care about this. Do you remember? In another problem, I didn't call it gold, silver, and bronze. I called it first, second, and third. I could call it president, vice president, and secretary. Okay, as long as I'm naming it something different, that's me telling you order matters. Okay, I'm going to show this one a little different. This is a permutation. I have 6 runners. I care about 3 of them, gold, silver, bronze. So that means gold, silver, bronze. 6 kids could get the gold medal, someone gets the gold. 5 kids can get the silver, someone gets the silver. There are 4 kids left to get the bronze. Okay, so I didn't even have to use a calculator. Right, there are 120 different ways. Okay, order matters, it's a permutation. Another way that they show this, by the way, is like this. Permutation, right? 6 kids to choose from. I'm choosing 3, and order matters. So now I'm going to show that a little, let's stick with that for a sec. So I'm playing with different ways you're going to see this written. Okay, the big P is the permutation here, right? When there are 2 numbers, it's permutation like that. So I have 8 kids or objects, and I care about 3 of them, and order matters. This is the same way to write it. That's how you write it. And you get your answer. Look at 6, right? And that's your answer. I guess I'll finish them for you on my calculator. Okay, so I'm going to use a calculator for this. 8 times 7 times 6 is 336 ways. Okay, now I'm going to do a problem with you that it confuses a lot of kids, so I decided to do this one with you. Okay, so phone numbers, right? People's phone numbers. Okay, so the beginning of my phone number is 801, right? 516 is the area code. I'm not talking about the area code. I'm talking about the first 3 digits of my phone number. It's 801. So a lot of people that live near me, the beginning of their phone number is 801. I think in Great Neck it's 443, right? So 516 is Nassau County. And then for me, 801 means you live near me. So let's read this one. In how many ways can a phone number be created? If there are 15 ways that the first 3 digits can be arranged, so I'm not doing the area code, right? That's a phone number. Okay. 15 ways the first 3 digits can be arranged, and then each of the remaining 4 digits can be any digit from 1 to 9, as long as no digit is repeated in the group of 4. Okay, so there's kind of 2 separate rules here, and I think kids aren't familiar with phone numbers, so I thought I'd do this one with you. Okay, the first 3 digits, okay, these 3 digits have a set 15 ways, 15 different numbers, right? Done. 15 ways, that's a given. They gave you that information. Now the next 4 digits. Notice there's no 0 there, which really isn't realistic. Notice they say the digits can't repeat, which also isn't realistic, but we're just doing what the problem says. Okay, so careful with this. There are only 9 digits, not 10, because they didn't give you 0. 9 different digits can go there. That doesn't mean that that digit is a 9. It just means it could be a 1 or a 2 or a 3 or a 4 or 5 or 6 or 7 or 8 or a 9, but it doesn't mean it's 9. It means there's 9 different choices. I'm going to pick any number to go there. It's not repeated. So 8 different digits can go here, 7 different digits here, 6 different digits here. I'm going to multiply these 15 ways times this. So on my calculator, now I'm going to tell you, use a calculator for this unit, but this is the type of work I want to see. I'm going to do 15 times 9 times 8 times 7 times 6, and I get 45,360 different phone numbers given this information. Okay, different phone numbers given that information. So really this is more of a reading question. Okay, so we're going to stop this video now, and I hope you had a good day. Bye.